Hello and welcome to another one of these ADD videos. Today we're going to be looking at a quotient rule example that's slightly advanced. It's got some fractions in it, and we're going to do the extensive algebra that I recommend you learn how to do. Some professors just want you to know how to do the quotient rule and ask you to do this at this point in the game, but when you're doing relative extrema and absolute extrema, when you're finding your critical points, it's easier if you do this type of algebra. So let's do it. First thing we got to do is we got to rewrite it. That's going to be an x cubed minus 1 to the 2/3, and the denominator is going to be an x squared plus 2 to the 1/5. Then you're going to use the Lodi-High, UV prime, whatever you want to call it, rule, quotient rule. So in this case, the bottom times the derivative of the top subtract 1, you're going to get a negative 1/3 minus 3/3 up there, times the 3x squared minus the top times the derivative of the bottom and then times the derivative of the inside. Alright, and then all that's going to be over this squared. But I'm going to leave that off to the side for now and clean this up. So to clean this up, what I got to do is first see if anything's going to cancel. And sure enough, this 3 and this 3 can go bye-bye. 2 and 5 don't cancel. Alright, so we're going to factor out anything that's a negative exponent, and we're going to factor out any fraction numerical coefficients, and if we have just positive exponents, we would factor out the lowest common power. But in this case, they both have a negative, whatever the base is has a negative exponent that I want to get out. So again, I'm going to put what I factor out in blue. Numerically, I want that 1/5 out of there, and then times the x squared plus 2 has a negative power of 4/5. I want that out of there, and then the x cubed minus 1 to the negative 1/3. Right? Do had over factor to figure out what's left. The 2. Ooh, I could have factored out 2/5. So let's go ahead and make this a 2. That way it'll cancel this one and this one out. And I just got a text message, it seems. Here we're going to have a x as well that I forgot. I'm sorry, people. So 2x can factor out because there's an x squared there and an x there. So what's going to be left? I'm going to have one of those x's left, right? And then x cubed to the or x cubed minus 1 to the negative 1/3 cancels, and then I'll be left with x squared plus 2 to the 1/5 over negative 4/5, so it becomes x squared plus 2 to the 5/5. In other words, just a 1. Then we go to the second group, and in the second group it's the x squared plus 2 to the negative 4/5 that disappears. The 5 is gone in the denominator, the 2 is gone, and the x is gone. So the only thing that's left is the x cubed minus 1 to the 2/3 over x cubed minus 1 to the negative 1/3. So what you'd be doing is 2/3 minus a negative 1/3. I'll just write it out for you on this one. And that gives you 3/3, which again is going to give you 1. And if you did this factoring properly, usually you're going to get an exponent of 1 here on these expressions that were pretty complicated prior to that. So distribute through on both sets of parentheses, combine your like terms, and that 2x plus 1 is a lot easier to deal with now. So we're going to have the 2x as well in front, and then everything else is on the bottom. Oops, it's a 2 there. let's just rewrite it. And then an x cubed minus 1 to the 1/3. Don't forget the 5. There's one more thing we're forgetting. What are we forgetting? The denominator squared. So that would be the x squared plus 2. And it was to the 1/5. So when you have 1/5 raised to the second power, it becomes 2/5. You multiply the powers. And then you notice that these two are like bases, so your final answer should be this here. Actually, you know what? I can distribute. You can distribute if you want to, or leave the numerator the way it is, because if you're finding critical points, you're going to set those individually equal to 0. And there's no sense in distributing when you're going to factor out here in a second anyway. But for those of you that did distribute, I want you to have a sense of completion there. But either way, the denominator should simplify into this. Two like bases, you add the exponents. And you get that right there. Alright? Or you could have this numerator with that denominator. Either one of those are acceptable. Alright, so I didn't want to put this at the end of the quotient rule example video, part 1, because it was already over 10 minutes long, and to do this would have been overkill for ADD type audience that I'm targeting. So make sure you practice these. They will come in very handy later on. If you get it out of the way now, you won't have to worry about it later. And thank you, and have a nice day.